Hello friends, good afternoon. In the last class, we derived the expression for the series resistance. Or when the number of resistors those are connected in series, its equivalent is the sum of individual resistors. That is, Rs is equal to R1 plus R2 plus R3. If n number of resistors are connected in series, then the value of a equivalent resistors is Rs is equal to R1 plus R2 plus so on Rn. Then here today we study about the parallel combination. So parallel combination is that when the number of resistors are connected across each other, the end-to-end combination is known as a series. And when the number of resistors are connected across each other, that is known as a parallel combination. So here parallel combination is that when number of resistors when number of resistors are connected across each other, that combination is known as parallel combination. That combination is known as a parallel combination. Then here, if we consider the three resistors, those are R1, R2 and R3. Then consider to derive the expression for the parallel combination, to find out the equivalent resistor of a parallel combination, consider the three resistors R1, R2 and R3. Consider three resistors R1, R2 and R3. Consider the three resistors R1, R2, R3. Those are connected parallel to each other. Parallel. Then see how to draw the figure. The three resistors are connected in parallel. So here, suppose this is a resistor 1, whose value is R1. Consider the another one resistor, whose value is R2. This is the symbol for the resistor. Consider the third resistor, whose value is R3. So these are the in parallel combination. Then when these are in parallel combination, so here across each other. So this type of combination is known as a parallel combination. End-to-end combination is known as a series. So in this type of when the number of resistors are connected across each other, that combination is known as a parallel combination. Then here when we do the potential difference, when we apply a potential difference to these resistors, or the potential difference is applied across this. So this is a battery, or this is a potential difference with a potential P, which is a connected across the three resistors with the potential P. This is a positive, this is a negative. This here what happened here, in which according to the Ohm's law we require the three values, that is a V, I and R. Then V is connected or V is externally given across the three resistors. Means the potential difference is applied to each register is the same. In the series combination, the potential is divided into the three parts and the current is the same in the series combination. Remember that in the series combination, the current is same, but in the parallel combination, that is a current is divided, but the potential is the same, which is connected to the across. Means the potential which is given to the first register, the potential which is given to the second register, and the potential which is given to the third register is the same. Therefore, when the number of registers are connected in parallel, the potential difference which is applied across the three register is the same that is V. Potential V is given to the register R1, V is given to the R2, V is given to the R3. Means the potential is the same for all the three registers. Then here what happens? When the potential is given, the current in the series combination is same, but due to the resistance those are different. The current is divided into the three parts. For example, see here, due to this potential, if I with the current which is flowing in the circuit, or if the I with the current which is flowing in this combination, but this I is divided into the three parts. This R is divided into the three parts because according to the Ohm's law, that voltage is directly proportional to the current. Means when we apply the voltage and due to that voltage, the current is also flowing. But what happened there? Due to the parallel combination, and the number of resistors have connected parallel. A parallel combination ಲಿಂದ potential ಕೊಟ್ಟಿದ್ದು ಮೂರು resistors ಗೆ ಏನಿರ್ತಾ ಸೇಮ್ ಇರ್ತಾ ಫೀನೆ ಬಟ್ ಕರೆಂಟ್ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಕರೆಂಟ್ ಆಕ್ಚುअल ಮೇನ್ ಸರ್ಕ್ಯೂಟ್ ದ ಈ ಮೂರು ಕಾಂಬಿನೇಷನ್ ದ ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗತ್ತ I ಬಟ್ ಇದು ಎಷ್ಟು ಪಾರ್ಟ್ಸ್ ಗೆ ಸಪ್ಲೈ ಮಾಡಲಾಗತ್ತ ಮೂರು ಪಾರ್ಟ್ಸ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ or for if we consider for the first register is the current is a I1. For the second register, current is a I2. For the third register, current is a I3. Means the I with the current is divided into the three parts. I with the current, total current which is flowing in this combination is a I, which is divided in how many parts? Three parts. Means what is I is equal to I1 plus I2 plus I3. Therefore, take the first equation. I is equal to, in the series combination, the potential is different, but the current is same. But in the parallel combination, the potential is the same, but which value is divided here? Current is divided. Therefore, consider the first equation. I is equal to the total current I is divided into the three parts. That is, I is equal to I1 plus I2 plus I3. So, here the equation number 1. Equation number 1. Then I is equal to I1 plus I2 plus I3. Then what is the Ohm's law here? V is equal to I into R. Then find out the value of I1, I2, I3. ಇಲ್ಲಿ ಯಾವ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ? Ohm's law ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. That Ohm's law is equal to V is equal to I into R. Therefore, R is known, V is known, I is known. Then find out the value of I1, I2, I3. ನಮಗೆ ಇಲ್ಲಿ ಮೂರು ವ್ಯಾಲ್ಯೂಸ್ ಗೊತ್ತವ ಆ ಪ್ರಕಾರ ನಾವು ಯಾವತ್ತು ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು I1 I2 I3 ಸೆಪರೇಟ್ಲಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಈ ಈಕ್ವೇಷನ್ ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ then find out the value of I1 that is V is equal to I into R. V is equal to I into R. Therefore I is equal to V divided by R. ನಮಗೆ ಯಾವಾಗ ವ್ಯಾಲ್ಯೂ ಬೇಕಾಗ್ಯಾವ I1 I2 I3 then find out I1 is equal to potential is the same for total circuit. What is the potential given here? V. Means V is the same. V divided by what is the resistance? First combination R1. Means in the first branch the current is a I1, potential is a V, resistance is a R1. Then find out for the second, that is I2. I2 is equal to, for the second branch, potential is a V, current is a I2, resistance is a R2. Therefore, V is the same because which is applied across the three combination. V divided by R2. Then, and I3 is equal to, see the third branch. In the third branch, current is I3, resistance is R3, but the potential is a V. Therefore, I3 is equal to V divided by R3. Substitute all the values I1, I2, I3 in equation number 1. Substitute the values of I1, I2, I3 in equation number 1. Therefore, the equation 1 becomes I is equal to V divided by R1 plus V divided by R2 plus V divided by R3. Equation number 3. So we find out the total current, that is I is equal to V by R1 plus V by R2 plus V by R3. That's here, if these three resistors are connected with the equivalent resistor. What is the meaning of equivalent? Equivalent is the sum of all the three resistors. That's here, this equivalent resistor can be found out by applying the Ohm's law. So these three resistors are connected by a one resistor, and that resistance is a equivalent of all the three resistors, and that is known as a parallel combination. This combination is a parallel combination. The potential is the same, and the resistance is known as a R3 because this R3 shows the parallel combination. So when there is a parallel combination, means RP is equivalent to all the three resistors. Then apply the Ohm's law for this circuit. Where current is I, resistance is RP, potential is V. Then when we apply the Ohm's law here, so what is Ohm's law here? I is equal to, therefore I is equal to V divided by RP. Equation number 3. Equation number 3. Then compare the equation 2 and 3. Then compare the equation 2 and 3. When we compare the equation 2 and 3, one side is same, so the other side is also same. So when comparing equation 2 and 3, comparing equation 2 and 3. So that is P divided by RP is equal to P divided by R1 plus P divided by R2 plus V divided by R3. PV, it cancel, take V outside. P divided by R3 is equal to V in bracket 1 by R1 plus 1 divided by R2 plus 1 divided by R3. Where PV get cancelled. Then what is the equivalent of the three resistors? Those are connected in parallel. What is the related formula here? 1 by RP is equal to 1 by RP is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. So in this type, when the number of resistors are connected in parallel, its equivalent is a reciprocal of all the resistors. In series that ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಡೈರೆಕ್ಟ್ ಆಡ್ ಮಾಡ್ತೀವಿ, but ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, that is a reciprocal is equivalent to all the resistors, means ಇಲ್ಲಿ direct add ಆಗಲ್ಲ, ಏನಂತ ಇಲ್ಲಿ reciprocal ಅಂತ. So this formula is a very important. If the number of resistors are connected in parallel, then what is the related formula? 1 by RP is equal to 1 divided by R1 plus 1 divided by R2 plus so plus 1 divided by R3. So in this step, we find out the related formula. So this formula is a very important for the numericals, and this derivation is not related for your theory exam. This year, this derivation is cancelled for this year. But the number of numericals, those are depend upon this formula. Okay, what is the series formula here? Rs is equal to R1 plus R2 plus R3. What is the equivalent when the number of resistors are connected in parallel? What is its equivalent? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here there are so many number of questions. Those are depends on these formulas, or those are depends upon the combination of the resistors. So here how to find out the equivalent resistor when the number of resistors are connected in series and parallel. Find out equivalent resistor. Find out the equivalent resistor when the number of resistors are connected in a series and parallel. Find out equivalent resistance. Equivalent resistance between A and B. Between A and B. There are number of figures are given in CET exam, in NEET exam. Let's see how to simplify these questions. Suppose this terminal is a A, this terminal is a B. The unit of resistance is a ohm. Let's see how to simplify this, how to find out the equivalent resistance in between them. Some figures are given. Let's see how to simplify these type of questions. First, let's see the figure carefully. When we observe that the 2 ohm, 2 ohm, these two resistors, when we straight this wire, what type of combination is this? Series. When we open this wire, or when we straight this wire, this combination is again what type of series combination. So here, when we simplify this in this type of, this is one resistor, this is another resistor, this is down 1 and this is a 2. This type of figure is find out. When you simplify this figure, this type of figure is find out. So each resistor is a 2 ohm. That is a 2 ohm, 2 ohm. We know that in the series combination, end-to-end combination is known as a series combination. So when the two resistors are connected in series, we know that the related formula is Rs is equal to R1 plus R2. Therefore, R1 plus R2 means 2 plus 2 is equal to 4. Same pattern. This is also Rs1. Second one is Rs2. That is also equal to R1 plus R2. Therefore, 2 plus 2 is equal to 4. So again we have got the two resistors. So these two registers are in the form of a, this is a 4 ohm and this is also 4 ohm. 4 ohm, 4 ohm. A and B. Can we simplify the figure? We have got this type of combination. These two are in series. So 2 plus 2 is equal to 4. This is also 2 plus 2 is equal to 4. But the next we find out the parallel combination. And we know that parallel combination is that Rp is equal to 1 by Rp is equal to 1 by R1 plus 1 by R2. Therefore, next one is a parallel. That is the 1 by Rp is equal to 1 divided by R1 plus 1 divided by R2. Otherwise, see here, if we take the direct formula R2 plus R1 divided by R1 R2, 1 by Rp. Cross multiply. Therefore, Rp is equal to R1 R2 divided by R1 plus R2. This formula is also equal. Use this formula. 1 by Rp is equal to 1 by R1 plus 1 by R2. Otherwise, use the similar formula. That is Rp is equal to R1 R2 divided by R1 plus R2. Simplify that. Rp is equal to R1 R2, that is a 2 into 2 divided by 2 plus 2 is equal to 2 into 2, 4. 2 plus 2, 4. Means what is the answer here? 1. So here the equivalent value is what? 1. So in this time we simplify the number of registers when the number of registers are connected in series or parallel. Next, this is another one type of figure which is given in the other competitive exams. This is 6 ohm and other resistors are of a 3 ohm. Then what is the equivalent resistor of this figure? Or what is the equivalent resistor in between A and B? They say how to simplify easily. How to simplify easily. So first to simplify that figure. When we simplify this figure, so here, this is the inside 6 ohm, this 3 ohm, 3 ohm, 3 ohm, 3 ohm, this is 3 ohm. Then first we solve from the outside to the inside. First simplify because here we want to find out in between A and B. Number A and B number in ಬೇಕಾಗಿದೆ. ಆ ಟೈಮಿಗೆ ನಾವು ಏನು ಮಾಡಬೇಕು ಅಪೋಸಿಟ್ ಸೈಡ್ ಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಂಡು ಹೋಗಬೇಕು. ಈಗ ಅಪೋಸಿಟ್ ಸೈಡ್ ಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋ ಟೈಮಿಗೆ see here this is a one line. Okay, in between this there are two registers are there. ಈ ಇಲ್ಲಿ ಇಬ್ರು ನಡುವೆ ಎಷ್ಟು ರೆಜಿಸ್ಟರ್ಸ್ ಅವಲ್ಲಿ 2. You state ಮಾಡಿದ್ರೆ ಯಾವ ಕಾಂಬಿನೇಷನ್ ಅದ series. ಈ 3 plus 3 is equal to ಎಷ್ಟಾಯ್ತು 6. 3 plus 3 is equal to 6. Then here 6. First one is RS is equal to R1 plus R2. That is equal to 3 plus 3 is equal to ಎಷ್ಟಾಯ್ತು 6 ohm. First one R1 plus R2 is equal to 6 ohm. Then simplify. This 6 ohm is a parallel to this. ಇದು 6 ohm ಏನಂತ ಇದಕ್ಕೆ ಯಾವ ಟೈಪ್ ಕಾಂಬಿನೇಷನ್ ಹಾಕೋತಾ ಇದು ಪ್ಯಾರಲಲ್ 6 ohm. ನೆಕ್ಸ್ಟ್ ಇದಕ್ಕೆ ಸಾಲ್ವ್ ಮಾಡಿ. ಇದು ಯಾವ ಟೈಪ್ ಕಾಂಬಿನೇಷನ್ ಇದೆ ಈಗ see this 3 ohm 6 ohm. What type of combination is this parallel? Okay, this end to end is the same, and in between the two resistors ಅಂದ್ರೆ ಯಾವ ಟೈಪ್ ಕಾಂಬಿನೇಷನ್ ಅದ ಇದು ಪ್ಯಾರಲಲ್. ಈ ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಸೆಲೆಕ್ಟ್ ಯಾವಾಗ ಫಾರ್ಮುಲಾ Rp is equal to R1 R2 divided by R1 plus R2 is equal to R1 R2 3 and 6. 3 into 6 divided by 3 plus 6. 3 6 are 18. 6 plus 3 9. 9 ones are 9. 9 twos are 18. ಅದೇ ಎಷ್ಟು ಬರ್ತದೆ 2. ಇದು ನೋಡಿ ಇವು ಎರಡು ಹೋಗಿ ಏನು ಬರ್ತದೆ there is another one equivalent resistor and the value of that resistor is 2. Then again 2 and 3. What type of combination? Series. That is ಇದು RS1 ಇದು RP1. Therefore RS2 R1 plus R2 3 plus 2 is equal to 5 ohm. 3 plus 2 is equal to 5 ohm. Then again simplify that. 3 plus 2 is equivalent to 5 ohm. Then remove these two resistors. There is a one resistor. And the value of that resistor is 5 ohm. Again there are two resistors. What type of combination is this? Parallel. Then what is the related formula from the parallel? Rp is equal to Rp2 is equal to R1 R2 divided by R1 plus R2 is equal to R1 is 3 into 5 divided by 3 plus 5. 3 5 is 15 divided by 8. 3 5 is 15 divided by 8 means 8 ones are 8 ones are 7 1.87. So the value is 1.87. Therefore, when the 3 ohm and 5 ohm are parallel to each other, the equivalent resistor is 1.87. So here, this value is 1.87 ohm. Again, there are two resistors. ನಮಗೆ ಏನು ಬೇಕಾಗಿದೆ in between A and B. In between A and B, how many resistors are there? Two resistors. And this combination is a series. Means 1.87 plus 3. Therefore, RS3 is equal to R1 plus R2. R1 is equal to 3 plus 1.87. 1.87 means the answer is 4.87 ohm. So 3 and 1.87 is equal to 4.87. So this combination is a parallel. Then find out the parallel. Rp is equal to R1 R2 divided by R1 plus R2 is equal to R1 is a 6 into 4.87 divided by 6 plus 4.87. What is that? 6 into 4.87 divided by 10.87. 2.60. 6.8. 2.68. So the answer is 2.68. In the annual examination, there are some 5 marks numericals are there. So say what up the last year question for the related 5 marks question. 3 registers, the NCERT questions. Three registers. Three registers. 1 ohm, 2 ohm, and 3 ohm. 3 registers. 1 ohm, 2 ohm, 3 ohm. 1 ohm, 3 ohm, 1 ohm, 2 ohm, and 3 ohm are combined in series. Are combined in series. Combined in series. What is the total? What is the total resistor? What is the total resistor? What is the total resistor of combination? Of combination. What is the total resistor of combination? Second sub question of this is if the battery is connected, 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 that is a 12 volt. Obtain the potential difference. Obtain potential difference across each resistor. Across each resistor. Across each resistor. This is a 5 mass numericals, which is a repeated in the annual examination. Let's here first draw the figure. 3 resistors of 1 ohm, 2 ohm, and 3 ohm. So see the figure. First one resistor 1, 2, and 3. There are 3 resistors 1 ohm, 2 ohm, and 3 ohm. Those are connected in a series. The battery is given. What is the battery potential here? That is a 12 volt. Then we know that in the series combination, which values are divided here? The potential is divided into the 3 parts. The current is same. So first solve the first part of the question. First part of the question is 3 resistors of 1, 2, and 3 are combined in series. What is the total resistors? So we know that the series combination is first one answer. Series combination RS is equal to R1 plus R2 plus R3. So that is equal to 1 plus 2 plus 3 is equal to 6 ohm. So how about the part? Is a 6 ohm. Then next part is find out the potential difference. Then to find out the potential difference, we require the value of a I. Okay, because according to the Ohm's law, V is equal to I into R. So V is known, R is known, equivalent resistance is also known. Then in the series combination, which value is the same here? Current is same. The resistance is different, voltage is different, but the current is same. So find out the value of it I by using the formula V is equal to I into R. Therefore, I is equal to V divided by R. So what is the potential given there? 12 volt divided by R. What is the equivalent resistance? 6. Then what is the current flowing through the circuit? 6 to the 2 ampere. 6 to the 6 7 the 6 6 to the 12. Means the current total current which is flowing in the circuit is 2 ampere. In the first resistance also 2 ampere. In the second also 2. Third also 2. Then find out the value of it. V1, the battery connected potential each other. Obtain the potential difference across the each other. So P is equal to what is the related formula? V is equal to I into R. V is equal to I into R. So the second part. Therefore V1 is equal to I into R1. Current is same in the series combination. I is now 2 into resistance. What is the resistance here? 1 is equal to 2. The voltage across the first resistance is a 2. P2 is equal to I into R2. I into R2, that's I is equal to 2. Into resistor is 2 is equal to 4. P3 is equal to I into R3 is equal to current is 2 into R3 is 3 is equal to 6. Another one, same type of question in the NCERT. This is also repeated question. This type of question or this type of question in annual examination. So here, three registers, 2, 4, and 5. 2, 2 ohm, 4 ohm, and 5 ohm are combined in parallel. And combined in parallel. What is the total resistance? Means what is the equivalent resistor? What is the equivalent resistor? If the battery is connected of a 20 volt, obtain the current across each resistor. So here in this question, there are three resistors. Those are connected in a parallel to each other. In the parallel combination, the potential is same, but the current is different. So the parallel combination 2 ohm, 4 ohm, and another one is 5 ohm. So first find out the equivalent resistor. We know that in the parallel combination, equivalent resistor, the related formula is 1 divided by Rp is equal to 1 by R1 plus 1 divided by R2 plus 1 divided by R3. 1 divided by R1 2 plus 1 divided by 4 plus 1 divided by 5. So take the LCM and find out. By using the LCM or by using the cross multiplication, find out the equivalent value. And the equivalent value is 19 divided by 20. 1 by RP is equal to 19 divided by 20. Therefore, RP is equal to 20 divided by 19. And that value is 1.053 ohm. 1.053 ohm. Is the answer for the first part. In the second part, the current through the R1, current through R1. That is R1 is equal to V divided by current. That is the current through R1 is equal to V divided by R1. So the potential is same in the parallel combination. That is a 20 divided by 2. So the current is a 10 ampere. Current through R2. V, that is the same, 3 divided by R2. That is the 20 divided by 4 is equal to 5 ampere. Current through R3. Is equal to V divided by R3. So V is a 20 divided by R3 is a 5. These 5 fours are therefore total current is equal to I is equal to I1 plus I2 plus I3. That is a 10 plus 5 plus 4 is equal to 90 ampere.